Hello all, welcome to our Aislyn Technologies YouTube channel. Today we're going to see a demo of deep fake detection project. Nowadays, in the rapid advancement of artificial intelligence has introduced various generative models offering convenience but also raising concerns. Deepfake poses several significant problems, ranging from ethical and legal issues to society and security concerns. Here, some of the major challenges associated with deepfakes: misinformation and disinformation. Like, deepfakes can be used to create misleading or false information. For example, they can produce realistic but fake videos or figures saying or doing things they never actually did, potentially influencing public opinion or spreading false narratives and privacy violations. Deepfake can be used to create unauthorized or offensive content, such as fake pornography featuring individuals without their consent. This can lead to significant emotional and reputational harm. First of all, and all among this, security risks a major issue. Deepfake can be used in various types of frauds, such as impersonating individuals in sensitive contents to gain their unauthorized access or commit actual scams. This is a problem statement, and I have used techniques like DD former, DD former. There is nothing but deepfake detection transformer. It's a model designed for detecting deepfakes. It uses transformer-based architectures, which are type of machine learning model, more for their effectiveness. Along with this, I have used MFT. MFT is nothing but multi-feature transformer. Is a type of model used for various tasks in machine learning and computer vision. It refers to a transformer-based model that integrates multiple types of features. For example, visual and textual for the robust performance. And I have used SWAF. Is nothing but similarity-based weighted average fusion. Is a technique used in various fields, including deepfake detection and multimedia analysis. It generally involves similarity measures. It's nothing but using similarity metrics to compare and fuse different data sources or their features. And now I'll show you our workflow. Based on this, we are working. First, I will upload my data set here, and then I will be processing. In this video, I'm splitting those video into frames and extracting the audio. I'm using pre-processing here. By after extracting the audio from the video, I'm doing it as audio spectrum for the training purposes. And by using feature extraction, I'm loading the training model frames and the audio, load the both models, and by using deep learning machine learning techniques like the SMT and SAM feature extraction, I've trained the model, and based on that model, I could detect the videos, whether it's a real or fake. Now I will show you the code. This is our data set. Our data set consists of fake video and audio, fake video and real audio, real video and real audio, real video and fake audio. Can see this. This is our data set. Now what I'm doing is feature extraction. By using your data set, I have collected every 20th count of the frames of every data set and I have uploaded into an image file. You can see this. I extracted this. In this, you can see all the 20th frame of the videos here. Now, along with this, I'm extracting audio spectrum based on SkyPy.wave file. Here, what I have done was I extracted audio spectral files of every spectrogram the frequency based on new spectrums of using some indexes of the frequency range to make the line spaces up and down so that it would be easy whether the trained model detect whether video is real or fake. Like this I have done. This is a plot order spectrometer, and your output will be saved here. I'll show you this output. Yeah, this is the output of audio. So audio output. You can see it's all a spectrogram of corresponding real video or real audio spectrogram is this. Now, what I'm doing is I will take the audio output and I will train with this with the CNN model. That is nothing but convolution neural network. It's a neural network model. Based on that, I could train all the spectrograms, and then I could detect whether the detected video is real or not. Here, what I'm doing is our target is 4, our path is audio output. This is our audio output. This is our audio output. Our target is 4. This is what I have mentioned here. Now, what I'm doing is, this is a pre-processing steps, and this is a taskbar. It's a TPDM taskbar. It's nothing but a progress bar. It will show the whether your training is how your training is going on. This is a progress bar, and then here to show the graph, how much your model is, how your model is lost, and then how your model is hit accuracy. And this here is stopping. Whether your model, if you go down, it could stop earlier and take the great accuracy to you. Yeah, this is for audio and this is for video. I've given both set. This is a trained model VLM, and this is for video purpose. After this, we will see our trained model CNN here. I will dump. Now I'll go to testing code. Here you can see this is our testing code. I'll dump our models here. I'll dump our models here. This is our trained model. Now what I'm going to do, I'm going to test this. This is our GUI. Here you can see the predicted frame is fake video or fake audio. For more tracking, yeah, after training the model, you should dump the model in the testing code. This is what I'm going to do here. In this code, it will predict whether the video is fake or not based on the trained model. Now I'm going to run this. Yeah, this is our GUI. In GUI, now I'm going to capture a frame. That is, I'm going to select a data set. I'm going to select a data in another data set. I'm going to select fake video and real audio. I'm just selecting a random state. Yeah, you can see this. Our predictive video is fake, and predictive video is fake, and the audio is real. Yeah, our model has found that the selected video is fake video and the real audio. For more interesting and detection videos, you can subscribe to Aislyn Technologies.